All right. Uh, so I appreciate if you can, keep yourselves on mute. So my name is Sahir Jasvi, and I am a technical sales consultant for Aviva. We are an industrial software company based. I'm based out of Dubai, but it's a global company. We have offices around the world, and we are the developers for Pro2 simulation software and many other simulation softwares, which I can introduce to you later on along the series of webinars I plan to do. Now, if you have any questions related to this particular webinar, you can write to my personal email address, which is sahir.jaspi@gmail.com. And if you want to write, maybe you are affiliated with a university or working for a company, and if you want to write an official email to me, then you can write to sahir.jaspi@aviva.com. So what is Pro2 simulation? It's a steady state simulator, which means that there are no time dependent phenomena calculations happening. If you look at the graph on the right here, which is power versus time, if you make a step change, for example, at time 0, it does not basically calculate what happens between time 0 to time 3. What has happened between these 3 minutes? It doesn't calculate this peak, for example. It will just tell you that you made a step change here, you got this final result. So this is basically a steady state simulator. Hence, controllers and instrumentation, these kind of units which are on a process are irrelevant, because it doesn't really do any control. It doesn't have do any instrumentation or measurements or something. Uh, Hence, these are irrelevant in Pro2. The other thing which we need to know about Pro2 simulation is that it's a sequential modular simulator, which means that units are solved one at a time. So let's say this is a very simple flow sheet where you have a few flash drums, you have a few heat exchangers, a compressor, and a pump. There is a default sequence Pro2 would follow for solving each unit operation. So um, it will solve one unit at a time. So first, let's say it will solve this flash drum, then it will go to the compressor, and so on. You can change the sequence of this of the calculation. However, by default, Pro2 has its inbuilt sequence, which it will follow. The second thing is it's a modular simulator, which means that it will solve one module at a time or one unit at a time. It doesn't write all the equations at one in a form of matrix or something like some of the equation-oriented softwares do. We also have an equation-oriented solver, which is in our different software, which we might talk about in later webinars. But Pro2 simulation basically doesn't do that kind of simulation. It will solve one module at a time. So it's all one simulation at a time. In Pro2, you need to know the feeds. So if S1 is my feed stream, you need to know the information for the feed stream. These internal streams like S2, S3, and all these, even if you don't provide any information for that, that's all right, because these are going to be calculated anyways when the simulation runs. Also, the product streams like S13, S11, or S9, the streams coming out of the as a product as a product, you cannot provide any information for that. These are basically calculated stream. So in Pro2, basically you need to know the feed stream conditions only. The recycles are handled automatically. So this particular stream, for example, S10 is a recycle stream. You don't need to provide any estimates for it. Pro2 can handle these kind of streams by itself. I do not know how to. Okay, fine. So just want to show you the environment of Pro2, how it looks like. So this is the environment of version 10.2, which is the earlier version to what we have right now. The latest version of Pro2 is called as Aviva Pro2 Simulation version 2020. And the graphical user interface of Pro2 looks something like this, where on the left side you would see a message window, this window. Here, all the error messages, warnings, number of iterations it has taken, all that kind of information will be appearing here in the messages window. This is your process flow diagram area where you will be building your flow sheet. And on the right here, you see something we call as a PFD palette, where you see all the unit operations which from which you can choose from to build your process flow diagram. Now, this PFD palette basically is divided in the form of tabs. You have a general tab, a pressure changer tab, columns tab, reactor tab. Depending on what type of unit operation that you're working with, you can find that in that particular tab. On the top here, you will see this ribbon view, which something very similar to what you will see in Microsoft application like Word or Excel. A ribbon view where you have all these icons that you will be working with, and on top you have the various tabs. So the tabs are like Express tab, File, Edit, Input, and so on. But in general, most often you will use the Express tab, which consists of the required icons or buttons that you would be usually working with to build a simulation. The next thing that we need to know about it as intro before we can jump into the demo and how the simulation is built is the color codes we have. If you see any button which has got a red border to it, or any data entry box which has got a red border to it, it means that this data or action is required on this particular box or a button. If you see a green border or a green box, colored box, then it means that there is some default data which is already there. And if you do not provide any more information, that's fine. So Pro2 can still run the simulation. Then if you see blue color, it's an indication that a user has supplied some numbers or some data in this particular area. It may be a button, made this data entry box. The user has provided some information here. And the yellow color, it stands for warning. So if you have provided some information, some number which really doesn't go with the property that you're trying to define. For example, if you are giving specific gravity as, let's say, 1,100 kg, 1,100, for example, which you don't see that kind of thing. You will see 0.1, 1, 0.9. I mean, in this kind of range, you'll see the specific gravity, right? So it will give you a yellow color, which indicates that there is a warning. Please have a look at that. Then finally, on the introduction, I'd like to mention that in Pro2, we suggest that the users, they follow these 7 basic steps to build a simulation. First and foremost is you check the units of measure. So if let's say you're working in a plant, you want to do the study on the plant on the process. You want to first of all build the plant on the Pro2 and then do the simulation. The first thing you'd like to do is see what units of measure the PFD or the designers have used on the plant. So you look at the PFD and then you look at the units of measure which are used there, and you select the same units of measure in Pro2. In technical support, when I used to work there, I remember that many of our tech support issues, they were or problems that were sent to us were based on or were because of the wrong units of measure selection. Then the second step is to define the components. So whichever components that you see in your process, may it be raw materials, may it be intermediate products, may it be a finished products, everything that you see in terms of chemical components in your process, you'll have to define that in your step number 2. Step 3 then defines the thermodynamics. Now, depending upon what type of process you're trying to model, that kind of thermodynamic method you will have to select. Sometimes it is very easy for us to understand what thermodynamic method to be used, but sometimes it is more complicated. So these are the times you can write to technical support of Aviva and ask them what thermodynamic method can be used, and we'll be happy to guide you with that. Then the 4th step is to build the flow sheet. And in the 4th step, when I say build the flow sheet, doesn't mean that you build a complete plant model without providing the information, without making without converging certain sections of the plant. The idea here is, when we say building the flow sheet, is that you go slowly, one step at a time. One section of the plant, converge that, and then you move it to the next section. That's the fourth step. The fifth step is then to supply the stream data. As I mentioned earlier, that Pro2 only requires feed stream data for the only the feed stream data. However, if you have the recycle estimates, it is better to provide that. I mean, because if it's a very large flow sheet, having some recycle estimates can make things go faster. Sixth step is then to provide the process condition. Sixth step is to provide the process condition, and the seventh step and the final step is to run and view your results. So these are the 7 steps that we suggest the simulation engineers to follow. And if you do that, there are less chances that you might make some minor or silly mistake because of which your model is not converging. So with that, I would like to now jump into the demo. So that gives you a much better understanding of how the simulator or software works. So when you open Pro2, sorry, this one's, yeah, when you open Pro2, this is how the environment looks like. So and as you can see, I'm on the Express tab here. I'm just going to go and click on New. And as I mentioned, there are sort of 3 windows that you can see, which is your message window, the flow sheeting area, and your PFD palette. So for this particular first webinar, we'll keep things very simple. I'll build a very simple model, and then we'll see how Pro2 works. So first of all, I'm going to go and select the units of measure. As I said, it's the first step. You click on the units of measure button here on top. As you can see, it's, by default, it is it's saying it's green color, which means that there is a default units of measure which has already been selected by Pro2. I click on that. During installation of Pro2, I had selected metric system as my default units of measure. So if I like that, I can keep working with it. If I don't like the metric unit for the particular process that I'm trying to build, if it is in SI units or English units, I can, as I showed here, I can click on the initialize from the UOM library, and then I can select, let's say, the SI unit, and then I can click on OK. However, if I'm not happy with temperature in Kelvin, I want to have that in Celsius, we can do that as well, and so on for other properties as well. If you want to have them manipulated or use a different unit set, you can use that. So for the moment, let's say for this demo, I'm okay with SI units and temperature in Celsius. So I'm going to go and say OK. Second step then is to select the components. And let's say we have a very simple system, a few set of bunch of components. I am going to say I have, let's say, methane, ethane, propane, and let's say ibutane. Now, if I have the name of the components which is less than 8 characters, as you can see, all of these have got less than 8 characters, 8 or less, the size of the characters for the name of the component, I can just type them here. But if I had, let's say, hydrochloric acid, for example, and if I try to write that H hydrochloric, it doesn't go more than 8, right? So if you have a component which has got more than 8 characters, for that you will have to click on select from list. Click on select from list, and here you will see the the bunch of components which are there in Pro2 that you can select from. The data bank that we use, a data bank, as you know, is a database where you see the components and the properties which are of those particular components are stored in those areas in that database. So SimSci data bank is the one which we should always use. And obviously then you can select whichever component that you want. As you can see, there are like over 1900 components in Pro2. Just for the demo purpose, I'm not selecting anything, but if you want, you could have just selected that, and then you click on add components. I'm going to cancel this. We are okay with ethane, methane, propane, and iButane. I'm just going to say okay. And then the third step is to provide the thermodynamics. Now click on the thermodynamics button. On most commonly used, let's use this Suave Red Liquang, and I'm just going to click on add. So now we are telling the simulation software that, okay, please use SRK as the thermodynamic method for calculating the various properties like K values, enthalpies, vapor densities, entropies, and so on. Okay, so the 3 steps done: units of measure, components, thermodynamics. Now the 4th step is to build the flow sheet. Let's have we have a very simple flow sheet. Let's say we have a flash drum, and say we have a compressor, and compressor, you will find it in the pressure changer tab, which as you know, as you can read, it's a tab which has got a set of unit operation across which you will see a pressure change. A compressor has a pressure change across it. In the same way, a pump will have a pressure change, a valve will have it. So we can, place all these unit operations onto the flow sheet. Then let's say we have a heat exchanger. So I'm going to go to heat exchangers tab. Let's take a simple heat exchanger and make it as an aftercooler from the compressor. So we have got all the units now onto the flow sheet. Now we can connect them all and complete our flow sheet. So let's click on stream, and then I'll click some on the open area onto the flow sheet, and then I will see all these red borders or ports where I can connect that stream. Okay, so I can connect it on anywhere on this edge of the flash drum. So I'll just click on some point, so it becomes the feed stream to the flash. Then I have the overhead going to the compressor, the discharge from the compressor going to the heat exchanger, and from the heat exchanger we have the product stream. In the same way, the liquid stream from the flash drum goes to the pump, discharge of the pump goes to the valve, and from the valve we have the product stream coming up. So when I right click now onto this on the canvas, the cursor will no longer have the stream selection mode. As you can see, the S will go away from the stream from the cursor. So I right click on it, so it goes away now. You can also click on zoom full. You have a better view than of your flow sheet. And now, as you can observe, there are some streams, unit operations, and a button on the Express tab, which has got red border, which means that if I try to run the simulation, it will tell me that all these are not defined yet. The data is incomplete for them. So I need to provide the information for all these ones. However, if you look at the pump does not have this red border around it, which it just indicates that if you double click on the pump, it tells that it has a pressure rise of 0 kPa as a default value, which means that if you don't provide any information here, it will just take a 0 pressure rise across it. Okay, so let's go ahead and define our stream and other unit operations. I'll double click on the stream. Then you can go to the stream type as compositionally defined. Click on flow rate and composition. We'll take the total flow rate, let's say, as 100 kg moles per hour. And then let's give some composition to methane, ethane, and propane. And let's say this is 0.4 iButane. We have the temperature at 25 degrees Celsius, let's say. We are providing the thermal condition, and the pressure, let's say, is at 300 kPa. So just providing the information for the feed stream. Then we go to the flash drum. Let's say the flash drum is adiabatic flash, which in other words means that there is no pressure drop and there is no duty. So let's keep it that way. No pressure drop, 0. Duty is also 0. And let's just say okay. Then after that, we can go to the compressor, double click on the compressor. Let's say we have the outlet pressure, or rather we can say that we have a pressure ratio of, let's say, 4. So whatever is the inlet pressure, the ratio of inlet to outlet will be like 4, um, 4 times basically. We have this AD, then let's define the efficiency of the compressor. Let's say it is just 70% efficient. And then let's go to the aftercooler, double click on that, and it tells you that only this part, the specification, needs to be defined. Click on the specification. Let's say we want to have the product temperature, which is S4, which is you know it's considered as hot product temperature, because in Pro2 any stream which goes to the tube side by default is considered as hot stream, and the exchanger basically tries to cool it down. That's the default configuration. So you can say that this hot product temperature, we would like to have that reduced to 25 degrees Celsius, let's say. And let's go to the pump and say we have the pressure ratio here of 2. And let's say the valve has a pressure drop of about 100, okay, let's say 100 kPa. So that was our 5th step to provide the to build the flow sheet and to provide the unit operation information. So 4th step was building the flow sheet. 5th step was to provide the stream information. The 6th step was to provide the information onto of the unit operations. And now the 7th step is to run the simulation and view our results. So I can now click on the run button. Earlier when we clicked on the run, it gave us the list of unit operations which had missing information. Now if I click on run, you will see that the color of the unit operations, it will turn blue, which indicates that these have converged. Some of them, like this pump and valve, they have stayed gray, which means that there's no flow coming here. So if I take my cursor onto the inlet stream for the pump, you see there's no flow here, and hence these have not been calculated. So to make that, to have some flow coming in, we can make some changes onto Flash. Let's go to the Flash drum and say that, okay, let's have a vapor fraction. Not that everything which comes in is vaporized. We say that it's only, let's say, 0.85 or 85% of the feed is vaporized. The remaining should go as liquid. So there will be some cooling which is taking place. So there should be some negative duty onto on this flash drum to remove some heat so that there is cooling, and then you have some liquid coming into the pump. So let's run this again. And now you can see that the pump has got converged. It is blue in color. There is some flow coming in. So, okay, so we have about 10 more minutes before the time runs out. So I'm gonna now show you how we can see the results. So for seeing the results, it's quite easy. You take the cursor and go to the stream of your interest. You can go to the units of measure, whichever unit operation you want to go and have a look at the results. So this is one time you can quickly have a look at what are the results on that unit operation or on that particular stream. Now, if you wanted to draw a table here on the flow sheet itself, you will have to go to output. You click on stream property table, and the cursor will have a rectangular box connected to it. Just drop it somewhere on the canvas. Then you double click on that. Then you select the type of results that you want to see. Let's say you want to see the material balance across your flow sheet, and you want to see them for all the streams. So you can see here, you click add all the streams and just say okay. Let's make it the display grid lines so that it is easy for us to read. And that's how you will see the results appearing. And this is live link, which means that if I change some numbers here, let's say if I make it 30 degrees Celsius, you will see that numbers will after running the simulation, after running the simulation, you will see those numbers will change, as you can see here. So this is a live link. So there are many other ways of looking at the results, but since we are running out of time, and I would like to open up now for any questions you might have. So please go ahead and unmute, or I will try to unmute you all. Need to unmute themselves. I think you will have to unmute yourselves if you want to ask any questions.
Yeah, hi sir.
Hi, Akshay.
Yeah, actually, can you please elaborate in which way can we compare Aspen HYSYS and this photo software? In how and in which way it is better than that?
I can't. I can definitely tell you what are the things that we have similarities, but I think it's not a good idea for me to tell you we are better, they are bad, or they are good, or I'm bad, we are bad.
No, I'm just talking about the whether it's a database or how, because user interface is almost similar for both.
Yes. So simplicity of working with Pro2 is quite easy. It's quite easy to follow the steps and build the simulation. If you look at the database as such that you were asking, we have in the select from list, you can see. So this is our primary data bank of which is called a SimSci bank, which consists of around 1900 or maybe just over 1900 components that you can select from. Now, if you don't have this the particular component that you're looking for, you can also look it up in the Dipper data bank, which is here. This is also coming from the Dipper organization. And if you're not able to find that component here as well, you can write us an email, and as far as I know that we provide the NIST data bank as well. So you can basically get information of any component that you're looking for. Now,
okay, can we enter the manually some compound with the properties in it?
oh yes, absolutely. So there is a very strong way we have here available, which is called as a thermodynamic data manager. So there is a I'll just show you where it is. Yeah. So the thermodynamic data manager, yeah, here it is, launch TDM. So in launch TDM, you can either regress a component as a library component. As you can see here, I have a possibility of regressing a component using this thermodynamic data manager into Pro2. Or if you just want to very simply define a component, you can have it defined as a petroleum component. For example, you go to petroleum component, you just give a normal boiling point and the standard liquid density or molecular weight, and you define it as a petroleum component. Or if you have the structure of the component available, you can also have it defined as a user defined component. By, let's say, I'll give the name, let's add it, and then we can go to the component properties, and you see here, right now these are all missing because this is a user defined component, right? So we can go ahead and
Okay.
fill it up as a unit, as a unifact structure. If you have the unifact structure for that component available, let's say that component A is some sort of alcohol. So you can say, okay, it's an alcohol which belongs to a certain group. Let's say it's 211. And then you say, okay, this type of alcohol group is already there. So there are various ways you can define a component which is not available in the library in Pro2. However, the strongest way is through launch TDM, because here you can basically regress experimental data for, let's say, if you have vapor pressure versus time versus temperature information available. You can regress that information, generate a correlation for calculating the vapor pressure for that new component, and have it included in Pro2 as a library component.
Okay, thank you.
Well, most welcome. So we have another 4 minutes left. If anybody else has any question, I'll be happy to answer.
Good morning, Shahir. This is Rami.
Hi, good morning, Rami.
Yes, Shahir, I see it in the simulation screen just now, HTRI global ANAV. What it mean? Is it we are going to do utilize, we can utilize with extra tokens, or how it is?
Yes. So if under the heat exchanger, we have a rigorous heat exchanger. This rigorous heat exchanger basically uh, has an possibility, depending upon if you have the HTRI license available for you with you. If you have that available, you can set up the initial design of the exchanger in Pro2, send the properties of the stream from Pro2 into HTRI, and then use the HTRI graphical user interface, design or rate the exchanger using the HTRI algorithms. So that is what it will enable or disable. But as such, I don't have that HTRI license, so I cannot demo this. So just for your information, that if you have HTRI license, you can design or rate the rigorous heat exchangers by taking the stream properties from Pro2 into HTRI.
Okay, it is interfaced already. Means Pro2 to HTRI, it can be interfaced.
That's correct. So when unfortunately I don't have it. So if I would have clicked on HTRI here, it would have opened up the HTRI interface for me. I could have done my changes there on the interface there, and Pro2 would have used the algorithms and the calculations from from HTRI, and my product stream would have had the results coming from HTRI then.
Okay, that model, it can be utilized over here, and the product stream, it will give the all the. And what about the report generation for the heat exchanger from HTRI? It can be downloaded from here also.
From here, not really, but here we have a very extensive report available for the heat exchangers as well. I mean, HTRI reports you will not be able to see it here. We have our own type of reporting.
Okay.
Yeah.
Okay, I got it now. Based on the HTRI, means say geometry of the exchanger, and all, if I change any parameter, we can see over here through the simulation, either steady or dynamic. We can see the results over here. Correct?
That's correct.
Yeah. Okay. Thank you. Thank you.
Most welcome. So now we have like a minute left. Sorry about this. I have this a basic version of Zoom, so last only for 40 minutes. I had a question on the chat, I think. Let me just have a quick look. Okay, you're very welcome.
Yeah, so I have one more question. Can we generate the TEMA sheets from this?
Oh yes, we can.
Okay, so it is through HTRI only. We need that license, right?
Okay, I'll have to confirm this. But as far as I know, HTRI reports we cannot get generated from Pro2. If you can drop me an email about your question,
yeah, sure.
I will check with our tech support people.
Okay, I'll do that.